All right. Hi, everyone. Thank you for coming. Thank you for the wonderful prior session. My goal today's presentation is to kind of zoom out a little bit and talk more generally about electronic textiles. It seems like at today's conference, a lot of folks are coming from the printed electronics world and kind of seeing how that can transfer over to e-textiles, but my goal today is more to talk about e-textiles as its own space and industry and where that overlap comes from based off of use cases and customer needs. So this is our agenda: e-textiles overview, technology landscape, market landscape, and example development. So let's start with the e-textile overview. I think in general, most e-textiles do not do novel things. They do things like heating. They can be used for HMI, cabling, sensing, and lighting. And so the main value proposition, if not doing very new things, is generally introducing drape or stretch. And that drape or stretch is useful largely for product design and making things that are easier for people to use, maybe more comfortable for them to use. So e-textiles really differ from standard printed electronics in that they have optionally stretchability. They are almost always drapeable or conformable. Otherwise, you can use a printed electronic on polyester. It's going to be cheaper. It's going to be easier to deal with in some ways. So only really if you need drape or stretch is where e-textiles can start to add value. And generally, we view this as value for product design. So this is an example of a device that we worked on. The original device looked like these images that you see over here. They're kind of bulky. They have a bunch of wires. One of them even has like a little pocket for all the wires to bundle in. And then when you start to use e-textiles, you can get things into much slimmer form factors. So this is basically a neoprene band with all of the electronics embedded within the neoprene. It's something that's much slimmer. It's much more productized. So sort of from our point of view, this is why these are worth working on. They can take things into more productizable, sometimes easier to integrate and use form factors. And so with that in mind, that e-textiles can provide integration benefits, generally these are the industries that we're seeing want these sort of integration benefits: automotive, healthcare and wellness, outdoor apparel and accessories, and some industrial applications. Each one has their own, these are just some proposed use cases, things that we've heard, but there are lots of other use cases as well. However, generally when you're using e-textiles, there's a technology trade-off. The softer and more flexible and pliable that you make something, generally the worse that it performs electrically. The more that you want to stretch something, the more that you start to run into electrical challenges. So this is the challenge that starts to come in with developing productive e-textiles to go into industry. And in general, if the application isn't really strong, then the cost is too high to overcome these issues. So looking more into the technology landscape, now that we sort of have some context for like this space and who might want to use it, what the general challenges are, there are diving more into this idea of drape and stretch, there are ways to characterize them, and then you can take that into the technology landscape and decide which technology makes the most sense for your product. So drape can actually be characterized using a drape tester. There's a drape coefficient, and generally it's calculated by looking at area that's covered by a material draped over a surface. And some applications actually don't really need much drape at all. In those cases, again, a standard printed electronic on polyester, or maybe even a Flex PCB will get you there. So these are good questions. Does it need drape? If not, then Flex PCB is probably a better option. This is just some sort of comparison of drape between different electronic materials. Kapton Flex is not very drapey. This is our technology down in the corner. Most printed ink on TPU solutions, or almost any of the e-textile solutions, will move like this. So I think that this is sort of the whole purpose of e-textiles, is to get drape while still maintaining as much electrical performance as possible. And then the second one is stretch. I say stretch is actually optional. Some applications don't even need stretch to perform, but in the cases that you do, I think that a lot of our companies, us included, say our technology is stretchable, but the most important thing is change in resistance over percent elongation and how that handles any sort of hysteresis or change over time. So there's also a question of, does your application need stretch? If it doesn't, it's much easier to do e-textiles on woven materials, things that don't stretch. Again, that will get you better